Bismillahirrahmanirrahim. My name is Muhammad Shoaib. Welcome back. In this video tutorial, we will learn about positive and negative transition in Siemens SIMATIC Manager. We will talk about how these transitions work, when to use them, and I will show you some practical example how we can use in the real life and how we can program in the PLC. So let's get started. So let's start with the basic. In a PLC programming, the positive transition edge occur when a signal change from off to on or from 0 to 1. This is also known as a rising edge. So as you can see it from here, the signal is in normal case is 0, and once signal change from 0 to 1, that is a positive transition edge or the rising edge. Meanwhile, the negative transition happen when the signal goes from on to off or from 1 to 0, also called a falling edge. So as you can see it from here, in the normal case signal was 1. Once signal change from 1 to 0, that time the negative transition or falling edge is happen. These transition are great for the triggering specific action only once. When a signal change, make them perfect for precise control in automation. The positive and negative transition are widely used in automation. For instance, a positive transition edge can start a motor with a single button press, while the negative transition can turn off an alarm once the button is released. These are essential in case where you want to control action based on momentary changes in the signals, making your logic more efficient and reliable. So let's understand the positive and negative transition concept in with a practical example. So we have a water tank, and our objective to fill water tank once the level is goes down, and once level reach at the high level, the pump should stop. So in the water tank we have two level sensors. One is the start level, and upper is a stop level. You can call that upper is high level and down is low level sensors. So for example, we are using the optical sensor for this tutorial. So assume that the water level is a middle of the tank. So and water is gradually going down. So once water level reach near to the lower sensor, and right now once the level is little bit above than the load sensor. So in that case, as the water is in front of the sensor, in that case, the sensor is active and the condition is 1 or true. So it's mean once the level go below than this sensor, it's mean the negative transition edge will happen. Like the sensor is normal case 1. Once the water level go down, so it's mean the 1 to 0 transition will happen. So once the negative transition will happen, the motor will start. Now motor start filling the water tank, and water is coming inside the tank, and now level is going up gradually. And once water level reach near to this sensor, so in that time the sense water is below than sensor, it mean the we are getting input from the sensor is 0. So we want once the water reach to the sensor, it means 0 to 1 transition is happened. That time motor should stop. So once the water level go up and reach front of the sensor, in that time the 0 to 1 transition is happened. It means the positive transition is happened, and in that time motor will become stop or the off. So let's see how in the PLC programming, how we can program this water tank as I explained it. So here is the program. We use the same negative and positive transition edge. So we take the negative transition edge first, and we assign the input sensor address I0.0, and then we'll take a memory bit that just save the previous status of the bit. So once the input is in normal case like 1 to 0 will happen, so in that case it will start the pump. And similar, once the transition positive transition edge like 0 to 1 is happened, in that time it will stop the pump. So let's do it practically, how we can program this example in a semantic manager. So we'll open the semantic manager. So step 7 wizard is open. So we'll create a new project. Just click next, select any of the controller according to your project requirement, then click next. I will select the lateral language, click next. So here I will put like positive and negative edge. That's project name, you can put anything. Click at finish. So we'll double click over the hardware. We'll assign some IO module in our project. So I will select one of the interface module, and then I will take one input output module. As you can see, our input output module starting address I0.0 and the output address Q0.0. And just click over the save and compile, and then close the project. Then click over the block and open the OB1 block. So our OB1 block is open now. So I will take like you will just expand the bit logic. And first I will take the this negative edge detection. So I will select and drag and drop it here. I will assign the input address I0.0, and then I will assign any memory bit address. It will just store the last state of the bit, and then I will take the set function, just select and drag and drop it here, and I will assign Q0.1, and I will put the symbol name like pump, water pump, and then I will insert a new network. Then I will take a positive edge, just select it, drag and drop it here, and I will assign the sensor name I0.1, and then memory bit M0.1, and from here I will assign a reset bit, that is address is Q0.0. So that's it, just save it. So I will open the PLC simulator, and I will select the interface, MPI interface, click over the run, and then I will just download this program inside the PLC. Yes. So you can see our controller is going in the run mode. Yes, controller is run now in the run mode. So I will click here to go in the monitor mode. So for example, right now our water level is the middle of the tank. So it's mean my water is in front of the lower sensor. That lower sensor is I0.0. So water is the front of lower sensor. That's why the load sensor is right now in the true form, like the in the true form. Okay, and what upper sensor is I0.1, so it's mean water is not from them, so it's mean that is a zero state. So now water level is going gradually down, down, down. So once the water level go the below than the load sensor, that is I0.0. So now water level go the below than I0.0. So my output, that the pump output is start and water pump is just started. So as you can see it here, the Q0.0 is now turn on. So now water is filling inside the water tank and water level is going rising up, up, up. So once the level reach on the front of the upper level sensor, so it's mean that upper level sensor in normal state 0. So once level go up for more than that sensor, so it means 0 to 1 state will happen. That is a positive edge. So here once the 0 to 1 state is happened, the pump is stopped. So the my pump is stopped. Now once the level goes down again, so goes down again, and when the water level is again goes down, again negative transition happen, then in that case my pump is running, and if the water level go up, then pump will stop. So like that. And if you want to view this in the function block diagram, so like that we can program it. And in STL also you can see like that, in STL we can program it. So Alhamdulillah, today in this tutorial video we'll learn what is a positive transition edge and what is a negative transition edge, and we also learn with the practical example of the water tank level how we can utilize this the positive and negative transition edge in a PLC programming. Thanks for watching this video.